Hello friends, welcome to this new video of this lecture series. This is the extension part of the last lecture where I discussed the setup time constant definition and concept. And this is a part of a mathematical equation of setup time, how we can discuss that. Let's see. So I think this same sequential circuit portion you already seen uh, various time. This is the same thing, but there is a simple change. Like insert a buffer into the capture clock path, and I also insert a buffer at the launch clock path. So before going to the step-by-step mathematical equation, there also we need to understand what is the arrival time and what is the required time. So the arrival time and required time is very simple here. That suppose from this clock pin, the data you already launch, clock sync pin, the data you already launch, it can go through the combinational circuit data path, and at this D pin, it will end. So this is the time. This is a path where the maximum time the data path can taken to arrive at this point. So this is the arrival time. Then the required time that at this D pin of this capture flop, there should be a timing specification from the tool STA tool. It can itself suggest or specify that by this time the data should arrive. Okay, so the arrival time should satisfy the required time. If not, then there will be a setup violation. We will see that. So let's come to the actual point. So as I said, that arrival time of the data at the D pin of the capture flop. So what it can be? Before that, we need to define some of the before that we need to define some of the timing parameter in this circuit itself. Suppose this is the T launch of this launch flop buffer insertion because of that, and there is a T clock to Q delay, and there is a T combinational delay, and you should take T combinational delay of maximum, and this flop have a T setup time already. It's given from the timing report, and it is coming from the IDEA tool itself. So what is the total data path it's taking to up to this D pin? Then what is the total time? Let's write it. The total time here is T arrival equal T launch plus T clock to Q delay plus T combinational delay, and it should be maximum here, and then T setup time, and required time for the data to settle by the flop 2s at the D pin. That required time should be, we need to define the T capture. So the T capture and the T clock, the clock's time period. So condition for the setup violation or to avoid the zero clocking is simple as that required time should be greater than or equal arrival time. Okay, you can say it as a equal or not as equal. Let take it as a required time should be greater than of arrival time. So properly write that the required time should greater T arrival. So write it T clock plus T capture T launch plus T clock to Q delay plus T combinational delay max plus T setup time. Then T clock, the time period of the clock should be T launch minus T capture plus T clock to Q delay, T combinational maximum plus T setup. And these simple things we say it as a delta. This is actually a skew. We will see later. If you know, it is very well for now, well for you for now. But this is a skew. We say it as skew. Take it as a skew. Delta TCQ T combinational maximum plus T setup delay. Okay. If there is a if that if this is the ideal clock, then that skew should be the clock to Q delay should be 0 and the setup time should be 0. We need that, but obviously it will not happen. So the again that the clock to Q should be would get as a T delta plus T combinational maximum. And if that delta is equals to 0, means we also take that clock skew is ideal. Clock skew is mean the both the clock path at flop pin flop launch flop pin and capture flop pin is same, no delay in between that. Then the T clock is greater than T combinational of maximum. You can say it as a T data also, T data maximum also. And it means that there is no zero clocking. Like we already avoid the zero clocking. Next, coming to the how we can avoid the setup violation. We can avoid the setup violation in the very simple way. If you follow this formula, you can say it very well. That if there is a time period is getting greater and greater, then there will be a very ample amount of time you will get to avoid the setup violation. But this is a trade-off. Like if you increase the time period, the operating frequency of the circuit will reduce. So you need to keep in mind also. Also, delay of the capture clock path, if decreased, then setup violation can occur. If delay of the data path is increased, then setup violation can occur. If delay of the launch clock path is increased, then setup violation can occur. So in this video, I try to cover the setup time calculation in mathematical way. Thank you for listening this video with your patience. Thank you.